Promising experience. I welcome, and the talk of this session is nuclear energy, right? Nuclear energy. And that's why we must have a very brief account of a nucleus. न्यूक्लियस के बारे में जो महत्वपूर्ण बातें हैं उसकी चर्चा मैं पहले कर देता हूँ. You all know कि atom has a center called nucleus. Nucleus, dimension of nucleus is very small, 10 to the power minus 15 meter. If you talk to the nucleus, and R, radius of the nucleus is of the order of 10 to the power minus 15 meter, and whereas the radius of the atom is of the order of 10 to the power minus 10 meter, right? And that's why the dimension of nucleus is much less than that of the dimension of the atom, right? Second point, the nucleus contains proton and neutron. उससे proton neutron होते हैं, and you all know proton is positively charged particle, neutron is neutral, and that's why the charge of the nucleus is positive. Very clear? You all know कि in atom relative mass of electron is much less than that of the proton and the neutron, and that's why the mass of the atom is taken as the sum of the masses of proton and neutron, and we call it the mass number, right? अब यहाँ पे देखें आप, the same thing is there. Atom has a nucleus. The nucleus is positively charged. The radius of the nucleus is smaller than the radius of an atom by a factor of course, 10 to the power 4, right? More than the 99.9% mass of the atom is concentrated in the nucleus, right? Now, next point. So, come to the next point. Mass of the nucleus or the atom is very, very small, and that's why it is very inconvenient to measure the mass and speak to mass in terms of kg or the grams. And that's why there is a unit, atomic mass unit, to measure the mass of the nucleus, mass of the atom, right? And one atomic mass unit here, one atomic mass unit equal to 1 by 12 into mass of one atom of carbon. Mass of one atom of carbon, right? And this comes out to be here, one atomic mass unit is equal to 1.660563 into 10 to the power minus 27. This is yours, 10 to the power minus 27, right? Next, come to the third. A nucleus, just I told you in the beginning, a nucleus has proton, positively charged particle, and a so-called neutron, which is a neutral. And that's why the charge of the nucleus is the charge of the proton. That is, the nucleus is positively charged, right? You know that the neutron was discovered by Chadwick, and for which Chadwick was also given a Nobel Prize in physics. right? Next point, say the atomic number Z is the number of protons in the atomic nucleus of an element, and the mass number A is the total number of protons and the neutrons in the atomic nucleus, and that's why here A is equal to Z plus M, right? What is A here? This is your mass number. This Z is your what? Atomic number. Listen carefully, and N is this your neutron number, right? Very clear. Neutron number means number of neutrons, and atomic number is the number of protons. Next, come to the next point. Say any nucleus species, it's your X, right? And X is represented by this ZA. Z stands for, you know, this is your, I told you earlier, this is your atomic number, and this is your mass number, right? Next point. So now we have to define something, say isotope, next isobar, next isotone. Very clear? Isotopes means same Z, different A. Isobar means same A, different Z. And isotope means same N. Number of neutrons will be same. Next, आज समथिंग मोर से फॉर एग्जाम्पल यू कैन उदाहरण कुछ देख लें इसके, जैसे से आइसोटोप, हाइड्रोजन, ड्यूटेरियम, and this one is tritium. It's highly unstable. Examples of isotope. Here are the same Z number 1, 1. Mass number are different 1, 2, and 3. Next come to isobar, and now you can see the examples of isobars as H13. This is your tritium, and next one is this is helium 2, 3. Here what you find, Z number is different 1 and 2, and mass number are same 3, 3. Next come for isotone, right? As the examples of isotope you can write here. Isotone, it's your mercury Hg 80, 98, and say Au gold 79 and 197 share. So the mercury, this is the Z number 80, and this is 79, and this is what, A plus N. Now 98 minus share 198, of course, here 198. So what you find here, 198 से घटा दो 80 को, क्या मिलेगा 811, राइट? आप यहाँ घटाएंगे क्या मिलेगा आपको 8 again 11. So here you find number of neutron be the same, 188. Here n 188, right? So the nucleus or the nuclear species having same number of neutrons are called isotons. And these are the examples. Next, come to more points. A nucleus, you all know, the size of the nucleus is very small. I told you in the very beginning. Radius is of the order of 10 to the power minus 15 meter. Radius काफी कम है as compared to the atomic radius 10 to the power minus 10 meter, right? And that's why there is a formula for the so-called the nuclear radius, and this is this way: R is equal to R0 into A with power 1/3, right? And the value of R0 is constant, right? R0 का जो मान होगा वो आपका constant होगा. This is the constant one. So you can write nuclear radius R varies as A with power 1/3. So now you have seen R was there. R is equal to R0 with A with power 1/3, and just here R0 is 1/2 femtometer. Remember, that's a constant. Very clear? Next point. Here, neutrons and the protons are bound in a nucleus by the short-range strong nuclear force. The nuclear force does not differentiate between neutron and proton. Understand? In fact, in the nucleus, what happens? Say this is the nucleus, and say they are the orbits along which the electron will move. Within the nucleus, say n plus n, neutron plus proton. You know, this is charge of this is 0 and relative is say +1. Say you take sodium. Sodium has atomic number 11. It means in the sodium nucleus there are 11 protons. 11 protons, right? The sodium nucleus. In the nucleus of the sodium there are 11 protons. आप सोच लो कि 10 power minus 15 मीटर का डायमेंशन है, और within the very very small range 10 power minus 15 meter there are 11 प्रोटॉन्स, 11 पॉजिटिव पार्टिकल्स है. आप सोच लो, कूलम के नियम के याद करोगे तो विद्युत के समान आवेश में विकर्षण होता है. मीन्स देयर विल बी दी रिपल्सिव फोर्सेस. मीन्स न्यूक्लियस के अंदर रिपल्सिव फोर्स काम करेगा अकॉर्डिंग टू कूलम्स. लेकिन आप जानते हो कि न्यूक्लियस स्टेबल होता है, कुछ कोड छोड़कर जो रेडियो एक्टिव न्यूक्लियाई होते हैं, जो बाद में इसकी सब चर्चा करेंगे. ए न्यूक्लियस इज स्टेबल. इट मीन्स क्यों स्टेबल है? To bring about the stability of the nucleus, say force, this is the Coulomb's force, this is repulsive, ये repulsive हो जाएगा, ये repulsive force, and say Fn nuclear force, right? अब क्या होगा कि this nuclear force Fn must be greater than Fc. मिस्टर न्यूक्लियर फोर्स जो अट्रैक्टिव है वो क्या होगा? कूलम्स के रिपल्सिव फोर्स से ज़्यादा होगा, टू ब्रिंग अबाउट दी स्टेबिलिटी इन द न्यूक्लियस. वेरी क्लियर? अब क्या है कि इसमें हमारा ये न्यूक्लियर जो फोर्स होता है, याद रखेंगे, कूलम्स फोर्स रिपल्सिव हो गया, बट न्यूक्लियर फोर्स इज शॉर्ट रेंज, कम दूरी पर काम करेगा, 10 power minus 15 मीटर के रेंज में काम करेगा. दिस इज अट्रैक्टिव. और ये क्या होगा? प्रोटॉन प्रोटॉन के बीच में भी काम करेगा, न्यूट्रॉन न्यूट्रॉन के बीच में भी काम करेगा, प्रोटॉन न्यूट्रॉन के बीच में भी काम करेगा. सो दिस विल नॉट डिपेंड अपॉन द चार्ज. ओके, दैट्स ऑल फॉर द डे. थैंक्स फॉर गिविंग मी योर पेशेंस एंड लिसनिंग.